larger threshold frequency, that means larger work function but the smaller threshold wavelength. So in this way we can draw the graphs between them. Now there exists a graph between stopping potential versus 1 by lambda naught. So if we compare with 1 by lambda naught, the relation will be Vs is hc by E into 1 by lambda minus phi naught by E. Here slope will be hc by E and intercept will be minus phi naught by E. So if we draw graph, the graph will be a straight line having slope angle theta, intercept minus phi naught by E. However, if we draw graph between two different metals A and B, then we can say that angles will be equal as they are equal to hc by E, which is a constant for all the colors. Then obviously work function for B is greater than work function for A, and threshold frequency, because they are directly proportional, for B is greater than that of A, but threshold wavelength will follow the inverse order. So in this way you can solve these questions. At last we have graph between stopping potential and 1 by lambda. So the relation is gonna be this, and we can use the intercepts of the graph, that when lambda is 0, V naught will tend to infinity, and at lambda is equal to lambda naught, stopping potential will tend to be 0. So graph will be like this, rectangular hyperbola, and that point will correspond to the threshold wavelength. If we have two different graphs, then we can say that from the graph that threshold wavelength for B is greater than that of A. That means work function for B will be less than that of A, and that means threshold frequency for B will be less than that of A. Now let's start with another question based on the concepts of stopping potential and lambda. So we need to draw find threshold wavelength for P. So obviously it is 3000 angstrom as given in the graph. Threshold wavelength of Q, it is 2000 angstrom as given in the graph. Next is work function of P. So work function is hc by lambda naught, we can calculate it. Then work function for Q, obviously hc by lambda naught, we can again calculate this. Then we need to find threshold frequency. So frequency is equal to phi naught by h, we can find it. Then again for Q we can find it. Then again we need to find which metal has larger threshold wavelength. So as it is evident from the graph, metal P has larger threshold wavelength. So as work function